So this is one of those tricky common interior problems. Like I mentioned before, anytime there's an overlap, we got to use some geometry skills to figure it out. We can't just use like regular polar equation setups to find the area. So that's the area we want, that overlap between the two circles. R equals 2 is the black circle. R equals 4 sine theta is the red circle. Okay. Even without the calculator, you can figure out where they intersect. Actually, okay, let's plan this out. Okay. So if you want the purple region, okay, here's the idea. And this is the easier method, okay, because it only takes one integral, okay, to do this problem, okay. So idea is this: we're gonna take the area of the largest circle, so red circle, okay, the area of red circle, okay, and then we're gonna subtract from this area right here. 1 second. This is where the calculus comes in. We're going to subtract the green area. Okay, and that'll take calculus. And once you do that, if you take the larger area, subtract away from this smaller top area, then you'll get the leftover purple area, which is what we want. Okay, so we just need to set up the integral to find the green area. Here it is. Okay, you can find these points of intersection by setting the two equations equal to each other. So 2 equals 4 sine theta. Divide that by 4, you get 1/2 sine theta. Theta is, what is it? It gives you 1/2 for these two angles, pi over 6 and 5 pi over 6. So this is theta equals pi over 6. This is theta equals 5 pi over 6. Okay, so we have our boundaries. Okay, so setup is this: pi over 6, 5 pi over 6. Okay, it's going to be the polar equation for the outer circle, subtracting away the polar equation that's inner or closer to the origin. So we do theta. All right, let's go ahead and plug everything in. Area of red circle, well, you can just use geometry for that. The radius is going to be 2. So it's pi r squared. That's 4 pi minus this. Okay, so that's going to be 4 sine theta squared minus 4 d theta. Okay, and so looking at the answers, it's in decimals, so that means we can use our graphing calculator. That's great. So I already punched it in the grapher. 4 sine theta is r sub 1, and 2 is equal to r sub 2. So I can go ahead and type it in using y varies as well. That's what it would look like. Okay. Divide that by 2, I get about 7.65. So basically, you're doing 4 pi minus 7.65, which is about let's take a look. 4 pi minus that's would be 4.91 roughly. There you go. Okay, so second problem. Length of a polar curve, all right, for this equation. You're going to want to use this equation right here to find lengths of polar curves, okay? If you're given the R equation, this is actually not bad at all. All you need to really find is the derivative of dr theta, but that means you're taking derivative of the original equation. That will give you 2 cosine theta minus 2 sine theta. So go ahead and plug this all in. limits of integrations given to you as well, from 0 to pi over 2. Okay, so 2 sine theta plus 2 cosine theta squared. And you can go ahead and punch this calculator as well. I'm going to do it a shorter way. I'm going to show you how. Clear this, clear that. Actually, I don't know if you, actually, maybe not. Okay, well, I'm just going to type these two equations in there. Oops. 2 sine theta plus 2 cosine theta. That's the first equation. And now the second equation is derivative. Let me double check my work real quick. It's good. I just realized I'm supposed to take the square root of this as well. We'll go ahead and type in the integral. To use my y-varies to play safe. Oh, that's right, I forgot. This needs to be under square root, so let me go ahead and do that in there. Dang it. Try that again. Wait a second. Square root varies 3, 1. Screw that. Plus. The answer, 4.443 roughly.